The first question that maybe comes to your mind might be, do I need a home lab server? And what could I use it for? I recently bought this little PC here secondhand on eBay for roughly 200 bucks. It's got an Intel i5 core 6th generation processor. I upgraded the RAM to 16 gigabytes and I added a terabyte SSD drive. That's plenty for what I want to do. I want to run a file server so that I can share my files with everybody in the house without having to upload them to a cloud service. I want to run my home automation software on it and maybe install additional software either in a Docker container or in a virtual machine for testing and learning purposes. Furthermore, we will install graphical user interfaces so that you don't have to fiddle with the command line or Linux shell. Stay tuned. Guys, please use the chapter markers and the timeline if you want to skip parts of the video. You can see the sections here on the timeline. Those are the chapters. I have also put them into the description. We don't want to get a huge electricity bill at the end of each month because we run that loud 500 watts engine. The one I bought should not consume more than 50 watts on average per month. So the cost of running it will be around $5 to $10 per month. Much less than my subscription to the gym, which I don't use anymore but still pay for. Enough talking. Let's get this thing installed. We will first need to choose an operating system to run it on, then install the OS, and then install a graphical user interface, a GUI, where we will do all the remaining tasks from. I have chosen Ubuntu Server version 20 because it's quite up to date with all the components and it is a widely spread distribution. In order to install it, I use a USB stick with Ventoy on it. If you want to know how to build this, then please watch this short episode from my Toolbox series. I have put a card up here on that little info icon, or you can access it from the description of the video. Installing Ubuntu Server is pretty straightforward. It's mainly questions and answers. That means the installation program asks you all kinds of questions, such as the region or country you live in, the keyboard layout which you want to use, the network configuration, etc. Where this is different from a desktop installation is the fact that everything is text-oriented rather than graphical interfaces that use the mouse. The only thing which I really want to pay attention to is to tick the box to have OpenSSH installed, because otherwise I will have no way to interact with the server later. Once I have answered all questions of the installer, it will start to copy files and set up everything. I can lean back and relax. Once it's finished, I reboot the system and I can then access it over the network using SSH. Cool! Now we have a PC with Ubuntu Server 20 installed. The next thing we want to do is install a graphical user interface to Linux so that in the future we don't have to fiddle with the command line anymore if we want to manage things on that server. The GUI that we will use is called Webmin. This is around for, I'd say, 20 years now. And it has constantly evolved. So let's get this installed. This is the first and the last time that we need to use the shell. You can do the following steps directly on the PC if you have a screen and a keyboard attached, or you can do it over SSH. I will install Webmin over SSH because my PC is already in the network rack in the basement. Webmin provides a Debian installer package, a .deb file, which can be downloaded from SourceForge. I have put all links into the description of the video, of course. Using wget or curl, I can download it to the server. Takes just a couple of seconds really, depending on the available bandwidth. Once the package is downloaded, I need to become root in order to install it. Installing a Debian package can be done with a dpkg command, then -i plus the file name to install. Takes a couple of seconds as well. Most probably, the install will fail and tell you there are a lot of packages that are missing. But there is an easy way to correct this. All we need to do is call apt with a -f option and the install command, and that will automatically install all missing packages and configure Webmin for us. Here we go, all done. While I'm still logged in as root, I might as well change the root password using the passwd command, so that's another box ticked on the list to make the server a bit more secure. That's it. Perfect! We have just installed the operating system and Webmin as a GUI to Linux on top of it. Now we can disconnect the keyboard and the screen and move the little PC to the basement or into our rack or somewhere where it's not in our way, as long as it has a power and a network connection. In IT terms, this is called headless. That means the server runs somewhere and does not have human interfaces such as a screen, mouse or keyboard. We will access it over the network. Now let's do all the subsequent actions using the Webmin GUI. First, we want to install Virtualbox and Docker. If the Webmin installation went well, then our system will be reachable browsing to port 10,000. Be aware that by default Webmin uses SSL, so HTTPS. That means you will get this security warning because the underlying certificate is not known to our browser. I will do a separate episode on TLS and SSL certificates in the future. For the time being, just confirm the exception. I can now log in as root with a new root password, which I had changed in the previous step. And here comes my Webmin interface. From here, I can do most, if not all, tasks that need to be done on my system, such as, in our case, install a software package. I just type in VirtualBox and then click on Install. That will resolve the dependencies and give me a list of all the packages it wants to install. It gives me that huge list of components to install, which I just confirm by clicking on Install Now. Webmin calls apt behind the scenes and pulls the packages from the Debian repository in the internet and installs and configures them for me. Next, let's do the same thing with Docker. The package we want is called docker.io, and that's pretty much the same procedure. I hope this already showed how easy it is to do tasks on the server using the Webmin GUI. Before we move on, let's just check if all software packages are up to date, and if not, quickly update them and reboot the machine. In the Software Package Updates section, I can see that there is a little reminder telling me that a lot of packages are outdated and need upgrading. Again, this is just a matter of 2 clicks really to get everything up to date. I click on Update Selected Packages, and after clicking again on Install Now, the system does everything for me. Once it's finished, I will see if a reboot is required. If a newer kernel is installed, then I will get this Reboot Now button at the bottom of the screen, so clicking on it will reboot my server. The same warning will be shown on the dashboard if ever a reboot is required. Awesome! All software packages are installed, we have a GUI, and now we want the same for Docker, of course. As a GUI for Docker, let's install Portainer. This is just a one-liner, and we can also do this from Webmin. Under Tools Command Shell, we have the possibility to execute a command on the server. You might remember the command from my Portainer episode. All we do here really is issue the docker run command directly with the right parameters. All details are, of course, in the description of the video. So let me just copy-paste the command into that input line. Once we click on Execute Command, then Webmin will launch the Docker pull in a shell and show us the output. Here's the full command line. Takes a while. Here we go. If everything went well, then we should be able to connect to Portainer by browsing to our server on port 9000. So let me just open a new tab and put that URL in the address line. Here we go, Portainer shows up and asks us to create an admin user. I leave the admin name and just type in a new password for Portainer. Once I click on Create User, then Portainer asks me where I want to connect to. Here I select Docker, so that's the outmost left option, and then I click on Connect. The Portainer interface shows up and asks me which Docker instance I want to connect to. I only have one, which is my lab server itself, so I click on the local bar And once I click on container, I can see that there is, of course, only one container so far, which is Portainer itself. Up and running. All good. Perfect. We now have a GUI to Linux and a GUI to Docker, which is Portainer. Before we can use VirtualBox, we need to do a bit of tweaking. The reason is that we want to use the VirtualBox Web Services, or API, in order to connect to the server, as we cannot access the GUI directly on the machine. Also, we want to make sure that VirtualBox does run as an unprivileged user for security reasons. First, we need to create a user for the VirtualBox Web Services. Under System, Users and Groups, I have already created that user. It's called Virtual. Let's check the options. Username and UID don't matter really. I set home directory to automatic, and very important, set the shell to /bin/false, because no one should use this account to log into the system. Therefore, we check the radio button no login allowed. Now, the group settings are crucial and need to be followed exactly in order to have a working instance of the VirtualBox web interface. The primary group needs to be VBox users. That will enable a lot of features around VirtualBox. In order to enable the VirtualBox web services to verify login information, it needs to be a member of the shadow group. This group has access to the /etc/shadow file and can therefore authenticate users with PAM, which is the Integrated Linux Security Authority. That actually cost me a day to figure out. So let's look for shadow in the secondary group and add it to the user. All other parameters can stay as they are. The next step is to tell the VirtualBox web interface to actually run under the context of that user. And if you Google for this, then you will find a lot of outdated information, such as changing the default config file, etc. That is really outdated, since Linux doesn't use initd anymore. So what we need to do is go to System, Boot Up and Shutdown, then find the vbox web.service and click on that link. This shows the systemd unit file, which will need to be adapted as shown on the screen. Here we specify the user and group, the executable which we bind to the right interfaces, plus we move the PID file to the user's home directory. Once we have made and saved all the changes, then we can restart that service. Again, disregard all the info you find in the internet. This is the way to go. Things have changed a lot in the last 2 years here. That's it. Now we have the VirtualBox web interface up and running, and we can now use a client to connect to it. For this exercise, we will use a software called Remotebox. There are other alternatives such as PHP VirtualBox, but they need additional configuration on the server. I might show that in a separate video. Let me know if you're interested. Please do leave me a comment. Let's download and use Remotebox. I will use this from a Linux machine. If you want to do this from Windows, then you need to do a couple more things. The documentation is on their website. Again, if you want me to cover this in a video, let me know. So let me Google for Remotebox. That's the link we are after. SourceForge or Knobgoblin. Again, please check the documentation on Ian's website on how to do this under Windows. Under Linux, I just download the bzip file to my workstation using wget or curl. I then unzip the file, change into that directory and call the Remotebox binary. Now, let me try and connect to my lab server. By default, the VirtualBox web services listen on port 18083. If you have not changed this, then it is sufficient to just type in the server name. I specify my username and password and click on Connect. Great, I'm connected to the server and can now add media and virtual machines to it. Cool, so Remotebox gives us the possibility to access VirtualBox on the server very much as if we were sitting in front of it. Before we can install our first virtual machine, we need an installation CD. Hey, let's actually use a Windows ISO file and install Windows 10 in our first machine. But how are we going to copy the ISO image over to the server? You may have guessed, we use Webmin to do this. Under Tools File Manager, we have direct access to the server's file system. I want to create a new directory in Mark's home directory, which I call ISO images. This is where I will put all of Mark's installation DVDs. Now, I select Upload File and I can either browse for a file or drag and drop it in that area. Let me pick that Windows 10 ISO file and upload it to the server. Good. The file is uploaded and I can now go back to Remotebox and tell Virtualbox about the new ISO file. Under File, Virtual Media Manager, I can add an optical disk. I browse to the file which I have just uploaded and confirm my choice. Now I can create a new virtual machine by clicking on the New icon. I give it a name, 2 GB of memory and a 50 GB hard disk, which I want to be dynamically allocated. So here we go, here is my new virtual machine. Next I need to go to the settings, and here I can change all the parameters very much like directly in the Virtualbox GUI, such as the processor, the RAM, etc. Here I add the ISO file. Please be aware that you would need to add it to an IDE controller, because presumably if you just added it to the SATA controller, like I did in my first attempt, then the VM would probably not boot. Cool, let me start that virtual machine and launch the remote display. The Windows installation launches and I can now go ahead and install a Windows 10 into that virtual machine on my home server. Okay, let's stop this here. I am quite sure you know how to install Windows. Awesome. We have a convenient small form factor PC running as an always-on home lab server with graphical user interfaces for all tasks, for Virtualbox and for Docker. Guys, I hope you liked this episode. If so, please do leave me a thumbs up. Next episode we will install another virtual environment which is a bit more enterprise or professional grade, called Proxmox. If you subscribe and check the bell or reminder button, then you won't miss that episode. Until then, many thanks for watching. Stay safe, stay healthy. Bye for now.